Section 8.6, and we're going to be talking about counting principles. It's going to kind of lead us into probability, but we spend this first lesson just talking about how to count up things before we get to probability, which we need to both be able to count and then determine how many things can happen, so the probability of it happening. So the first part we're going to talk about is cards in a deck. Lots of students I have found over the years don't play enough cards, and so I kind of got to go through what's in a deck of cards. And you're going to get this little card in class. So if you're not familiar with a deck of cards, you can use this in your homework and on the test, and I'm suggesting several things that you can add to it. So if you draw a line right above the tens, these are all the face cards. If you've ever looked at a deck, these are all the cards that actually have faces on them, a face of a king, a queen, and a jack. These are each of the suits. So there are 4 suits. These are spades, hearts, diamonds, and clubs. There are 13 of each suit, which means that there are 26 black cards and 26 red cards. What else do I need to tell you? There are 4 of each number of cards, so there's 4 aces or 4 eights. Some different types of poker that we play, or cards that, or hands that we play with. Poker is a 5-card hand. You're going to see these in your notes. Yeah, definitely your notes and then on some of the worksheets. So poker is a 5-card hand. A straight just means that all the numbers are in a row. So you have a straight of like 6, 7, 8, 9, 10. Just 5 numbers in a row. A full house means 3 of one card, like 3 queens, and then 2 of another card, like 2 kings. So as long as you have 3 of one card and then 2 of another, you have a full house. Straight, full house, I think that's good. I'm betting you know what 3 of a kind means. It means you have 3 of the same type. And a flush, that would be the other one. A flush just means you have all the same suit. So you have 5 cards that are all hearts or 5 cards that are all diamonds. Okay? So our first example here is in a box there are slips of papers with the number 1 through 9. On one piece of paper is drawn. The number is written down and then returned to the box and you draw a second number. How many different ways can a sum of 12 be drawn? And most students can make this list pretty easily. It's not that tricky. I just suggest to kids that you start writing things down in kind of a systematic way. So the first draw, if you were to get a 1, is there anything you could match it up to that would get you a 12 for a total? And there isn't. If you drew a 2, there isn't. If you drew a 3, there isn't. If you drew a 4, you could draw an 8, and that would make a combo. So 5 and 7, 6 and 6, 7 and 8, and then 8 and 4. And then anything, these 3 guys right here, if I draw 1, a 2, or 3, there's no way I can make a sum of 12. So they're just saying how many different ways can that happen? It can happen 5 different ways. How many different pairs of letters are there in the English alphabet? So a pair means 2 of them. So there are 26 letters for me to choose from. And then it just says different pairs of letters. It doesn't say I can't repeat them. So I'm going to say another 26 letters. And so 26 times 26 gives me 767 combinations of letters in the English alphabet. In the U.S., telephone numbers currently have 10 digits. How many different telephone numbers are possible within each area code? So our area code starts off with the first 3 numbers. Then you have the 3 next numbers that are kind of your local. Kind of narrows it down to where you are at. And then you have your actual extension. Okay, so we're talking about these 7 numbers. We're not talking about the area code. We just want to know within each area code how many numbers are possible. So a local phone number cannot begin with a 0 or 1. So out of all the digits that you could have, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can't have a 0 or 1, which means there's only 8 options for you to fill that blank. After that, you can repeat numbers in a telephone number, and you can have 0s and 1s starting here. So now there's going to be 10 options for you in each of these, because you can repeat numbers in a phone number. And if you were to multiply that out, you'd find out that there are 8 million different phone numbers that can be made within each area code. Permutations is something you've done before that you've seen. In a permutation, what you need to pay attention to is the order of the objects matters. Okay? So the number of permutations of n elements is n factorial, and you've seen this button too. Let me quick show you where it's at on your calculator. If you hit the math button, which is right here, 3rd button down on the left, and then go over to PRB, you're going to find your NPR and your NCR, along with your factorial button. and then you can use any one of those on the home screen. So if you wanted to do 8P3, you would just hit the 8 first, go do the NPR button, and then hit a 3. Okay? The number of permutations of n elements taken are at a time, so I'm arranging things so many at a time, follows this formula, and this is just the formula that your calculator is doing, or that my calculator just did with 8P3. So 8P3, and your calculator just does this formula, this side being the n and this side being the r. So you have 8 objects and you're arranging 3 of them at a time. So what your calculator just, or my calculator actually just did was 8 factorial over 8 minus 3 factorial, which is 5. Next up, how many permutations are possible with the letters A, B, C, D, E, and F? So you're looking to rearrange them, and you can't repeat anything because permutations means that the order matters. So once I use up a letter, it's gone. So we can draw 6 blanks, and when I pick the first letter, there are 6 choices, and if I put a B there first, then B is out, and that means there's only 5 left, and then 4, and then 3, and then 2, and then 1. This is the same as 6 factorial, which is the same as 6P6. You have 6 letters and you're actually picking all of them. You're looking to rearrange all of them. And when you put that in your calculator, you get, 720. Next up, 8 horses are in a race. How many different ways can the horses come in first, second, or third? So first, second, and third place. There are 8 horses. All 8 of them have a shot at first place. Once that first place horse crosses the line, then there's only 7 left for second place, and then 6 left for third place. This is the same as 8P3. I have 8 horses and I'm picking 3 of them to win first, second, or third. And if you do that, you get 336. How many ways can the letters in banana be arranged? This one's a little tricky because now we have repeating letters. So even if I rearranged this and moved all the A's around, you wouldn't be able to tell because they are the same letter. So we start off by just counting how many letters I have to arrange, and I have 6 factorial to arrange. And then I have to essentially divide out my overlap. I have to divide out every time I had a repeat. And so I have A that repeats, and there are 3 A's. And then I have 2 N's that repeat, and so 2 factorial. And when I do that, I get 60. There are 60 different ways to arrange those letters so that you actually can tell the difference. Next up, we've got combinations, which is the other button on your calculator, the NCR button. And in a combination, the order does not matter. So now I'm talking about just, hey, 5 kids come here. And it doesn't matter which student comes to me first, just as long as I get 5 kids. So the number of combinations now, this is the formula for a combination. Again, not vital that you know this because your calculator is going to do it for you. But this is what it's doing each time. So next up says how many different ways can 3 letters be chosen from A, B, C, D, and E. And I don't care what order I get them in. I don't care if A comes to me first or B or C. I just need 3 of them, whichever 3. So there are 5 letters, and I'm going to choose 3 of them, which gives me there's 10 different ways to pick 3 letters. Next up, here's our poker question. Standard poker hand consists of 5 cards from a deck of 52. How many different poker hands are possible? So when I am getting my hand, I'm sitting at the table and they're dealing the cards, it doesn't matter when they're dealing. It doesn't matter which card I get first, just as long as I get 5 cards. That's why this is a combination and not a permutation. If it doesn't matter the order in which I get the cards, then it's 52, choose 5. So out of the 52 cards, I just need 5 of them. It doesn't matter how they come to me. So 2,598,960 different poker hands are possible. You are forming a 12-member math club, and you've got boys and girls to pick from, and the team must consist of 5 girls and 7 boys. So how many different teams are possible? Well, out of the 10 girls, I need 5. And it does not matter how I pick the 5. It doesn't matter who gets picked first or picked last. I just need 5 of them. And then I have 15 boys, and same thing. I need 7 of them, and it doesn't matter how I get them. It doesn't matter how they're picked. There is no benefit to being first or last, so that's why I'm using a C and not a P. And I end up with 1,621,620 different ways for me to make my new math team. So today was all about permutations and combinations, knowing the difference between when the order matters and when it does not.